Hello everyone, and welcome to another tutorial on MINEDW, the 3D groundwater flow modeling software developed by Itasca. In this video we're going to review one of the main features of MINEDW, which is the simulation of an open pit mining plan. Before diving into the capabilities of the software, it seems important to us to cover some basic concepts about mining plans and the hydrogeological importance of time, and only then to review the concrete way to implement this in MINEDW. To answer the question, what is a mining plan? We can indicate that it is the materialization of a development strategy for a mining project. The plan is built from the best compromise between economic aspects, mining methods, operational restrictions, and mining sequences. Geomechanics and hydrogeology play a fundamental role in the validation of mining plans, since those are the disciplines that determine the feasibility of developing the project in safe conditions for people and equipment, in accordance also with the acceptability criteria of each operation. Then, from a conceptual perspective, it is relevant to establish that time is highly relevant in hydrogeology. Although in geomechanics, different photos of geometric configurations of a rock excavation can be analyzed in a relatively independent approach, from the hydrogeological point of view, the input associated with each geometry requires, as input data, the time in which each geometry occurs. This is justified by the resistance to flow offered by fracture media normally found in mining sites, where parameters such as hydraulic conductivity, specific storage, and specific yield determine the reaction of the flow to changes in boundary conditions. Let us now see the implementation of a mining plan in MINEDW. To start, we need to have the model open, and we need the topographies that will be interpolated as a mining plan in DXF format. In the menu on the right, we can see that MINEDW can import files of BLN type, which we will also use shortly, and DXF files. In this menu, DXF is where we will open the topographies at first to generate the necessary inputs. We double-click DXF, and then we will open the file that has the topography. In this case, we have 10 topographies for 10 different years, and we will start by opening the topography of year 1. The topography is loaded, and when we deactivate the other elements of the plot, we can actually see the associated surface. Now, in the DXF attributes, we can export the data file that will contain the points of this topography, and that is what we need for the interpolation of the mining plan. We select that option, and then we save this topography in a folder with an intuitive name. We click Save, and the model will begin to export those points. Once this has been done for the first topography, we repeat the procedure for the rest of the topographies. Once we have gone through the last year of the mining plan exported as text file, we need a file that contains the points of a polygon representing the horizontal envelope of the mining plan. That is, a polygon that encompasses the project area for this mining plan. The file must be in BLN format. The BLN format file contains in its first line the number of points of the polygon, and then the subsequent lines contain each of these points in terms of their x and y coordinates plus a z coordinate, which in this case can be z as 0 or any other value since it does not influence the process. In the interface, we select File, Data, BLN. We will open this file, and once the file is loaded, we shall see this polygon representing the maximum extent of the mining plan in its last stage. This will allow interpolation of the nodes that are within this polygon in MINEDW, and therefore they are the ones that will be modifying their elevation as the mining plan advances. Once we have the BLN file created and the text files for each of the topographies that we are interested to interpolate, we are going to create the mining plan for MINEDW. We will then go to the menu Mining, Create Mining Plan, where we will set the folder for the files that we will interpolate, that is, the point files that we exported previously. At this point, MINEDW asks for the name of the polygon that we just created, which in our case is called ultimate_r0.bln. The next step is to configure the dates of the mining plan, the file that represents the excavations, and the interpolation method, which by default uses a depth reference. Now we're going to give it the start date of this mining plan. We will simulate an excavation that starts in January 2001 and whose first year ends in December 2001. We will give it the name of the point file that we had exported previously and which represents that topography. Once we have the first date configured, we go to Add, and by default, the start date will be defined for the next topography by taking the previous end date and the same temporary space that we had before, in this case 1 year. Then we go to the year 2 and so on to complete the rest of the years. When we have configured all the years that will be interpolated, we can take a look at the interpolation options. In this case, the default works quite well for most cases, so we will leave it as it is. This configuration can also be saved in case it is necessary to replicate or modify this mining plan later, so we hit the Save button here on the right. Now we need to save the mining plan file, which will then be imported into the model. Once we have everything configured, we give it a go and the interpolation begins. When the interpolation of the topographies is done, we need one more step, which is to import the mining plan file into MINEDW. First, we will show how the topography in this case remains constant in the model when advancing the time steps, and then we will see the changes. So, to import the mining plan, we are going to go to the Mining Open Pit option. We will click the Add button, and we're going to look for the file created within the same folder that was the miningplan.dat file. We are going to open the file and it will load with the main features of the plan: its start date, its end date, and the elevation of the pit floor. Give it OK and it will load. Now, to visualize, we simply advance the time steps and see how the excavation shows. And as it progresses, we also see the hydrogeological units that are loaded in this model. Well folks, that's all for now with this video. I hope you found it useful. If so, please give it a like and remember subscribing to the Itasca channel. Thank you very much for your attention, and we hope to see you visiting soon in another MINEDW video. Cheers!